Okay, so what we're dealing with today is we're dealing with welds, joints, positions, how they all apply to print reading, and how they apply to certifications. So that's really kind of going to set everything up for the actual weld print symbols next week, and because these terms have to be known and how they work. Okay, so we start with. So we're almost kind of making a start here. So we start with welds, and one of the things I want to mention before we kind of go ahead is that if you do start looking at the book, you're going to see that there are a couple of them I'm not really going to cover too much. And the main one I'm not going to cover is either a spot weld or a seam weld. The spot and seam welds tend to be more dealing with production welding, especially with robotic systems, and how you kind of do sheet metal. So we're really not dealing with that type of stuff here. We're dealing more with heavier fabrication, with structural, with piping, things like that. So these two welds really don't come into play. Even though there is a section in there that shows print symbols and everything else, that's really not what we're talking about here. There's two more that I do want to mention really quick, but we're not going to dwell into too long. And that is a plug and slot weld. So let me draw this out so you can kind of see what I'm talking about. So say we have two pieces of steel that we got to put together. Where would we weld those?
The front bottom.
Oh, okay. Are you talking about over here? Yeah. Okay. All right. What about the sides? Could we weld the sides? Yeah, absolutely, we can. Except for, what if, when we go to do this, you were then told that this is going to sit into an area that has very little tolerance on the sides, and there's a piece that slides across this, so you can't have a weld here. That's where these guys come in. So what we do is we drill a hole, but only through the top piece. We leave this one solid, and we start welding that hole up. So basically we're plugging the hole. We weld it all the way up, fill it all with this molten weld, get up to the surface, then you can take this and either machine it down or you can grind this down clean. And now these two pieces are joined without any outside welds. That's almost it right there. I mean, there's really not much more variation, except for you could either have a bigger plate that has multiple plugs, it could be multiple slots, whatever it is. All we're dealing with basically is this shape or this shape. Now there are print symbols that say this, but they don't really deal too much more. I mean, there's a technique to do it. We're not really talking about techniques, but once it's done, that's it. I mean, there's nothing really to kind of keep going with this. But we're going to deal with two other welds that are really the meat of the print symbols. Okay? So understand what this is. You will actually see it at some point, but it's not going to be that big of an issue as far as
not too cold.
I want to see actually some long ones where you're overlapping. So do some longer ones.
All right. What is it, by on the right track?
Kind of. It's hard to tell on just that.
Okay.
So
Across the whole thing?
yeah. So this, remember it like this. You'll see one of these come up in our 102 class, and you'll also see it come up in our 110 class when you get there. But other than that, we're not going to really go too much into it. So what we're going to really focus in on are these two welds. A groove and a fillet. Now the groove, you're going to see, is a weld, and it's going to be a surface preparation. And we'll talk about the surface preparation after this. So we're going to just strictly stick with the welding part of this. So let's try to define a little bit about what is a groove weld. So we take these two pieces, we put them together, and we're going to weld it right here. That is going to be the first groove weld that we do. Now, what is one of the defining things for this is that the surface area, the surface that you were welding, basically run parallel to each other. It falls into the same thing if we just welded this little piece here. Again, that surface runs parallel to each other. Now, on the fillet, we're going to draw this one. Now we're going to weld here. But if you look at how those surfaces meet up, they run perpendicular to each other instead of parallel. All right, let's put some joints down on here. Okay, we have a butt T, lap, edge, and corner. Whenever we look at a mechanical print that's going to have areas that are going to be welded, every one of those joints will fall into those spots. You're never going to see one that's going, well, it could be this or it could be this. No, it's pretty defined. It will be either a butt joint, a T joint, a lap joint, edge joint, or a corner joint. Now, let's start out here. What do you think this one is? What kind of joint? This one right there.
Butt joint?
Yeah, it's two pieces butted up together. We're going to call that a butt joint. Now we're going to put down a couple key things here. So because I used that as the description for a groove, we're going to say that all butt joints are groove welds. What joint is this one?
T joint?
Everybody agree? Joint down there? T? Why is it a T?
This is upside down T.
Okay. Sounds like a stupid question. I've had people go, why do you call it a T? Because it's spelled, how's it spelled up there?
Oh.
Yeah, you could, yeah, it doesn't look like a golf tee, you know, so I mean, yes, it is though. It's a T joint, don't worry.
I'm sure that's why they call it that, because it looks like a T. I mean, they rarely just call it.
It is. They actually just spelled it out for some reason. So we're going to then now give you this And we're going to say that all T-joints are fillet points. All right, so now we're going to go to the lab. Okay, we're going to weld this area right here. Now, what kind of weld is that? Okay, fillet. Yeah, absolutely. Same thing. Look at where the surfaces are. They run perpendicular to each other. Absolutely, it's a fillet. Let's look at an edge. And we're going to weld this one right there. So, what kind of weld is that? Groove. Yeah, those are running parallel. The surface is running parallel here. If we weld it here, same thing. So absolutely. Okay, corner. What kind of weld is it?
Fillet.
Re-welding that one.
Okay. Yeah, that's absolutely what I'm kind of looking for. What I didn't give you here was where the weld was. It's the only thing I left off on that. So if it's on the inside, it is a fillet. If it's on the outside, it's a groove. Right. So the point on that is always when you're looking at your print, make sure you understand where the weld is going. Because although here, that's a fillet and that's a fillet, this is a fillet and this is a fillet, that's a groove and that's a groove. But when you do look at that one, there's two different techniques for welding, a groove and a fillet. So if you are prepared to weld it one way, but you're actually welding on the other side, it's going to be a little bit different. So always make sure you understand where the weld is going to be going. Okay. So yeah, so laps are fillets, edges are grooves also. Corners are the only ones that can be either one, depending on where it's at. The other thing that can throw things off a little bit is if it's lined up a certain way, because the other way we can line this up is like that. And now what do we have? Two fillets. Yeah. Yeah, bottom here and here. So, you know, just kind of watch those corners. Corners are always a little different than the rest of them.
I got a question.
Yeah.
A lap one.
Yeah.
Would that one also be a groove if you had to put a bead on the outsides? Like say you needed the inside clean because it was like something was slotted to go in there?
It's not necessarily, because you're not going to groove the surface. You would only put a little bevel here, and you're still technically doing a fillet at that point. So now we're going to go to positions. So we have flat, horizontal, vertical, and overhead. Now, if we were talking about welding technique, we would actually split the verticals, because to weld vertical up is different from welding vertical down. But here, we're just going to call it vertical and vertical. This is only talking about prints at this point, okay? But let's think about the positioning on pieces of steel. Okay, so if we look at this one, what kind of joint, what kind of weld? Butt joint, groove weld. What position?
Flat.
Okay. Now, what defines that position?
It's like flat on this one.
Not what defines that position. We're going to stick with stick welding right now, because it's the easiest one for me to kind of show you. All flat position welds come straight over the top, and in this case, with the rod, we're going to establish one angle, and that's a drag angle, and we're going to drag that across. Okay? So only one angle. Now, what joint, what weld?
T-fillet.
T-fillet. What position?
Horizontal.
Why?
Because your
Because you
angle
said
is-
this was sitting flat on our piece, on our table. That's sitting flat on our table too.
Or you're laying a well.
See, so it's more about the welding of it, not necessarily how it sits on your table. That's the point. So actually we can find it even more. When we need to weld this now, we have to actually come at this a little more horizontally. And what we end up having is this angle here, and then we have the drag angle we have to establish. So all horizontals have two angles we have to deal with, not just one. Now, if we wanted to weld this in flat position, not that big a deal, it's just that we've got to make sure this is propped up, kind of like that. Now I can come down over the top of it, one angle, and drag that through. Right? What joint? Left joint. What position?
That would be horizontal.
You agree?
I was gonna say flat.
Okay, so can I effectively weld this coming straight over the top of it like this, do you think? It's not really working its way up if I do it that way. So yeah, I do still have to come at it more at this angle. So I've got one angle and another angle for drag. So two angles. So this is now still horizontal. What position? Horizontal. Now, the thing is, people will often say, well, yeah, but you can go straight at that and it only has one angle and that's your drag angle. No, not necessarily, because we have this little thing called gravity that wants to pull the weld down. So now we have to actually kind of point up at it. So that's one angle. Set our drag angle, we're still at two angles for horizontal. What position? Vertical. Up or down? Vertical. Vertical is vertical. Can't really screw that one up. If it's going up or it's going down, it's going to be a vertical. What position?
Overhead.
Okay. Does it have to be over my head to be overhead? No. Be surprised at how often I go back there and people are reaching for it. Well, I thought it was overhead. No, it could be 5 inches off the ground and still be an overhead weld. Although at 5 inches off the ground, a pain in the ass to try to weld, but still an overhead. So we're just coming up at it underneath. So this would be a T overhead. If we had this like this would be a horizontal lap. But if we actually turn it around, now it's a overhead lap. Flat butt, overhead butt. That's all it is. Now, that make sense? Good. So, let's talk about certification for a second. So when a CWI goes into a business, we're not really talking about that type of certification. And if a guy goes in, if a CWI goes in there, they would either be testing either procedure on a product or testing or qualifying a welder for that product. It's really not what we're talking about here. What we're actually talking about is we're talking about certification for a welder that may not have a job at this point. Why I say it that way is because we have this bit of generic certifications that can be done, and those are kind of based on thicknesses. They're going to be based on watch the camera a little bit. Thicknesses, process, positioning. Those are kind of the criteria. So now it's not based off of a product; it's based off of a couple of other criteria. Do you have a quick question?
That's the outside, that's opposite side. So if I'm talking about this, I'm thinking opposite side. There's a quadrant right below it, that's right. That's opposite.
Oh, I'm sorry. No, you're right. Yeah, let's go with that. It actually can be both ways. Yeah, it could be. Yeah, it could be. Yeah. Yeah. But you're not going to run into a ton of those unless it's all sides. You just have to put what's 1, 2, 3, and 4.
Yep. Oh, like a quadrant, no.
Yeah.
I see what you're saying. Okay.
So, so when we do that, and if you're going to see an ad for a business, they may actually ask for a certain certification. So when they ask for a certain certification, usually, although let's be honest, half the time they actually don't know what they're looking for. They just someone's told them to look for this, but that's beside the point. Okay.
That was the last one.
That's better. Yeah, this is way too slow.
That was a thicker rod.
Yeah, it's still too slow. You could actually do thicker rod, but with a quicker dab, and still make it kind of narrower. But yeah, that's closer to what we're probably looking for. So let's run a few more of those. But what I want you to try to do is try to dab a slightly bigger jump. Let's see if you can kind of get that a little bit of angle. It's a little tight. Okay.
Grab the piece, or are you
Good on that. All right. So what am I talking about there? So what will end up happening, and let's take, for an example, maybe not, guy this morning didn't have any clue. Have you heard of U.S. Steel? Or over at E-Course off of Jefferson? You know, big place, big steel. They require their guys to get, if they want to have the mechanical guys get the top pay, they need to be certified, or they actually need to be qualified. Sometimes they do certification, sometimes they don't. And they ask their guys to be either, they want them to be both 3G and 4G certified. Okay? So, there's a reason why on the positions, I actually numbered those. You notice on nothing else I number, but on the positions I number. So we're going to go back to this side, and this is way easier than you think. (3G). So what is a 3G?
It's the 3 positions.
So no. It's a vertical weld with a butt joint. It's a vertical position butt joint groove weld. So it's just a plate, 2 plates put together, vertical, and you're doing it as a groove. That's all it is. If it's 4G, it's an overhead butt. It's a groove weld. That's the G. They may ask you for a 2F. So a 2F would be a horizontal T, and that's a fillet weld. That's the F. Pretty simple, right? So I want you to understand that there is always only 4 positions. Like I said, in technique, we kind of split up the vertical into 2 more. Vertical up and vertical down, but in terms of just positions, no, there's only 4. So if I were to give you an example on my quiz, it would be how many positions are there in welding? And I gave you 3, 4, 5, and 6. The answer would be 4. So I'm going to put a little wrinkle in that though. Doesn't really change that answer, but then this is where people got screwed up though, is that we're going to throw pipe into the mix. Because AWS does pipe, ASME does pipe, API does pipe, so they all do pipe. So what happens with that?
What, multiple positions?
Well, let's start with this one. What position is that?
As it says right now.
As it says right now.
The horizontal.
Okay, so what designation would this be if you needed to be certified for that pipe right there? 2G, absolutely. Think about this, if I split it and pulled it out, it's just a plate. The only difference is that it's in a circular shape, so I would weld it, turn it, weld it, turn it, weld it, instead of welding across the plate in one shot. You just have to turn it a few times. Same thing. So this one falls right into this. The two that are the wrinkle is this. If I do this, now I could make this really, really easy, and if I said that we can turn this pipe as we weld it, what position would this be in?
But if you turn it like, oh, if you turn the pipe, it'd be overhead.
No.
No.
What do you think would be the easiest way to weld it?
Flat.
Flat. So if we were able to turn this, we could call this a 1G. Because we could weld right here.
Couldn't it also be a 4G too? If you were to say the pipe's up here, technically that would be overhead, wouldn't it?
Hold on. But that would mean that's in a static position. Most times if it's going to be up like that, you're not going to be able to turn it. So now, let's think about this in terms of a clock. If this was not able to be turned, what position are we at here? At 12 o'clock, or at 6 o'clock? That'd be overhead. What position are we at 3 o'clock? Vertical. What position are we at 12 o'clock? Flat. So now we have 3 positions that this would be welded in. This is called a 5G. Okay? Vertical, or overhead, vertical to flat. So this would be a 5G if you can't turn it. Now, we take this and put it on a 45-degree angle. Now, at 6 o'clock, what position do we have?
Overhead.
3 o'clock?
Vertical.
So it's still vertical. 12 o'clock? Actually horizontal. So now this is 6G. So we expand those a little bit when we start adding multiple positions to it. So yeah, multiple positions if it's in a static spot. You can't turn it. And then, so this is technically kind of the hardest one for certification. We can make this a little harder, and it's actually what's called putting a restrictor on it. So it puts a ring on there so you can't see it that great. That makes it even harder, but not a lot of people do the restrictors. I would assume maybe they do it in nuclear, but for normal pipe welding, that restrictor doesn't be used. So even though we have a 1G, 2G, 3G, 4G, 5G, 6G, still there's only how many positions? 4 positions. Right. That's why I said don't let the 5 and the 6 kind of screw you up. It's just multiple positions of the same positions. It's not new positions. Does that make sense? All right. So the next thing we're going to kind of talk about now is we're going to talk about, go back to the groove weld for a second. And like I said, groove welds are welds, but they also are edge preparations. Because when we start doing the prints, the symbol for it is going to actually tell you how the edge has to be prepped before welding. All right? And it's actually not that difficult. It's just that we're expanding the names a little bit. So that one that I drew up here, which we call butt joint, we're going to kind of draw that again. But we're going to leave a separation here, and that's on purpose. Okay, so it's really kind of looking at the center area. What shape do we see there with those dotted lines? Square? Don't be a critic of my drawing. Jesus. Square. So this is actually called a square groove. Now, when we put an angle on a piece of steel, that is called a bevel. In machining, that's often called a chamfer, but in welding, it's called a bevel. So, because it's only on one side, this is a bevel groove. What do we see there? What letter? V groove. What letter do we see here? J. J groove. Now what letter do we see in this one? U. U groove. That's pretty simple, right? Each one of those actually has a print symbol separate for square groove, bevel groove, V groove, J groove, U groove. And actually we can then double those up to be a, not really a square, but we can do a double bevel, a double V, a double J, a double U. Not double U as a letter, but two U's. Just so you know. So if you think about the V and do a double V, it would actually be like that. Okay? So we can double those up. So we're going to get into all those print symbols.